Hello class, this is going to be a bit of a strange video. The audio apparently never recorded when I initially recorded the video, so I'll be recording the audio afterwards. So if things don't sync up so well, that's why. Briefly, we're just going to review the properties of a parallelogram. Firstly, the definition is that the opposite sides of a parallelogram are parallel. You'll notice I give the top and bottom ones 2 feathers and the ones on the left and right 1 feather. It's because they aren't all parallel, only the ones that have the same number of feathers. Opposite sides are also congruent, so we're marking those as well. Also, they don't all have to be congruent, therefore the top and bottom ones had 2. Opposite angles are congruent, so we're marking those to have the same number of hash marks as well. But also remember that the adjacent angles are supplementary, because in a parallelogram, the sides are technically same side interior angles, and same side interior angles are supplementary. And the diagonals of the parallelogram bisect one another, which is why the diagonals are split into 2 parts that have 3 hash marks and 4 hash marks. And what I'm doing and circling on the screen here is that the adjacent angles are supplementary as a reminder. There are 3 additional parallelograms that we need to talk about. They are the rectangle, the rhombus, and the square. If these parallelograms have this additional property, it will be considered also a rectangle, a rhombus, or a square. A rectangle is just a parallelogram that has 1 right angle. Now you might know that a rectangle happens to have 4 right angles, but that's because by the properties of a parallelogram, the adjacent angle will have to be supplementary, therefore 90 degrees. The opposite angle will have to be 90 degrees as well, because it's congruent, and then the other angle would also be 90 by supplementary angles. So a rectangle is defined as a parallelogram that has 1 right angle in it. It also has all the other properties of a parallelogram. It also has one property that is strictly unique to a rectangle, and that is that its diagonals are actually congruent. Now, a rhombus is a parallelogram in which all 4 sides are congruent. I guess technically we should say the definition is 1 pair of adjacent sides are congruent, because if 1 pair of adjacent sides are congruent, that would by default make the opposite sides congruent. A square is a parallelogram that has the properties of both a rectangle and the properties of a rhombus. So it contains at least 1 right angle and 1 pair of sides are 1 pair of adjacent sides are congruent, but it still has all the properties of parallelogram. Now, another property of the rhombus, which I forgot to mention in the video when I originally recorded, is that the diagonals of a rhombus are perpendicular, so they form right angles. We'll be moving on to the kite shortly, but do know that all 3 of these shapes are always parallelograms. The kite, which we'll talk about in a moment, is sometimes considered a parallelogram, but only in a certain circumstance. So a kite is defined as a quadrilateral in which has 2 pairs of adjacent congruent sides, meaning if the 2 sides next to each other are congruent and then the other 2 sides are congruent as well. Now, in the scenario in which case all 4 sides are the same, technically that does meet the definition of a kite, but it would also have the qualifications of a rhombus. And as we said, a rhombus is a parallelogram. So in the scenario in which all 4 sides of your kite are congruent, not only is it a kite, it is also a rhombus, and not only is it a rhombus, it is also a parallelogram. Now, a trapezoid is a different type of shape altogether. It doesn't really have congruent sides. It can have 2 congruent sides, and that would make it called an isosceles trapezoid. We'll get there in a moment. I forgot what was actually said at this point. I apologize. All right, so the trapezoid is defined as a quadrilateral with 1 pair of parallel sides. Therefore, it can never be a parallelogram, because if it had another pair of parallel sides, it would not be a trapezoid by its definition. Now, it could have 2 congruent sides on the left and right side, in which case it would be called isosceles. And that's pretty much going to wrap up all of the different types of quadrilaterals that we'll be learning this semester. We'll be seeing more about their properties as the class goes on. Make sure you answer the questions on the Ed puzzle, and I'll see you on Tuesday.